Mark Jones, thank you so much for joining us today. Welcome into this Machine Heads conversation. How you doing today, man?
Doing very well, Wayne. How are you?
Good, man. So yeah, we're going to talk a little bit today about CTL grade control options that you guys at Topcon offer, and to just go ahead and get right into the conversation. The kind of the first thing I want to talk a little bit about kind of like the market itself and the demand, and obviously like the compact track loader market still doing very well. I know I've spoken to a couple of manufacturers who, even despite kind of like the equipment market overall maybe kind of dipping in demand a little bit this year, CTL still doing very well, still lots of demand. I still think obviously that category is growing and we still haven't reached all the ways that those machines, obviously can be used. One of the ways that, it's growing in use is clearly like grading applications. So yeah, we just want to talk to you guys a little bit about machine control. But let's start with a question for you on an overview of kind of demand for grade control technology, specifically on compact track loaders. It's been around now for about, the technology in general has been around now for about 20 years. But how did demand for this specific technology start on the CTL with a compact machine like the CTL? And how has it kind of evolved in maybe the last like 5 to 10 years?
So when we talk about machine control, I think you're spot on. It's been machine control has been, widely accepted for the last 20 years. And, when we go back 20 years ago, the compact track loader, it's been around. The compact track loader, I mean, before the compact track loader, we were really looking at the skid steer. Now with the manufacturers adding tracks to the machines in place of the wheels, this utility machine has really gone into a bunch of new spaces. So when we've been doing machine control for 30 years. When we go back 20 years ago, really the cutting edge product was 2D machine control, being laser receivers and putting those on machines. So as the compact track loader is really, taking a big step into the market, the evolution of machine control has, allowed us to go with a 3D offering for those machines, and the emergence of grading attachments that are a lot more sophisticated than what they used to be has just made it a very nice spot to be in. We're a long shot away from where they used to be using drag boxes and a bucket here and there. So the grading attachments have really brought up the sophistication and the opportunity for CTLs to be used in more and more spaces.
Yeah, I mean, and kind of following up on that, you mentioned kind of like the evolution of the actual attachments as well. Give us an idea of kind of like what kind of attachments contractors are making the most use of. I know there's dozer blades now. There's like first party integrated options, which I know that you guys have worked with various OEMs to kind of help out on, in addition to your third party solutions. But like, what types of attachments and what types of jobs or specific types of grading tasks, I guess in general, would grade control grade control equipped CTLs are being used on today?
Yeah. So the attachments is a big play. And it used to be that everybody kind of knew what a box blade was. And what a box blade was, let's put really a box in place of a bucket, and let's push some material around the job. And then the step up from that was putting your laser receiver on there so that you could get a little bit of height. And you, as the operator, you could look out and say, okay, I need to drive it down a little bit, bring it up a little bit. But what we're seeing is just a big jump into the attachment segment. Now, you mentioned some of the OEMs are offering a dozer blade type attachment. We're still working with, so really the four attachments that we focus on, and we can do more past that, but we look at, yes, the dozer blade is out there, but so is the box blade. So there's been improvements made to the box blade. They do a lot more things. They have a lot better response time. They're a smooth operation now. The grader blade has really been kind of the eye-opening spot for contractors to use this. Instead of trying to find a very small motor grader, now they can assign this machine task to their compact track loader by putting on the attachment. So the grader blade attachment itself is allowing all of those fine finesse moves that a grader could in this smaller package. So the blade can rotate, the blade can pitch, they can side shift. So there's a lot of places that attachment can go. And the attachment companies are seeing that. So we're seeing, really a number of players getting into that space as aftermarket attachments. So OEMs are furnishing their own attachments, but there's a lot of aftermarket attachments that then allow for that to go to any brand of compact track.
Yeah, and when it comes to that, I do kind of want to divert a little bit here too. You mentioned the motor grader blades. When is that? And I guess you could really apply this to really kind of any of the blade considerations in general. What is that kind of like line of demarcation where like contractors kind of decide like, yeah, for this job specifically, I don't really want to have to get like a full size dozer or let alone like an actual motor grader in here, even a small one. It would be just a lot more convenient. What types of jobs are we talking about where it's just really handy to have like a motor grader attachment, or sorry, a grader blade attachment, box blade, or another kind of blade that you can throw on a CTL and get more benefit out of that machine?
Well, so if we look at the various segments, if we look at the heavy highway contractors that have been friendly to machine control for a long time, they have these CTLs on their job sites. They're doing other utilitarian type jobs. So how do they do it in the tight spaces? What can they do? Sometimes it's dozer, it's too big to get in there. Or it's almost ready for grade. So what do they get into these finite spaces with? They can now put this attachment onto their CTL, take the bucket off, put on the attachment, and do some of those tasks. And when it's done, they still use the CTL for the other stuff they're doing. If we look at, the smaller jobs, they're not the, what jobs that are going on for a year at a time, building a big new heavy highway that's federally funded. There's just a lot more urbanization going on. So with all those subdivisions, what comes up? Well, a strip mall. And these strip malls have got to be better and prettier and have a whole lot more things. It's a long shot from where you just paved out a parking lot, threw some gravel down, paved over it, and it all drained out to one side. Now we've got lighting fixtures, and we've got palm trees, and everything's got to look a whole lot better. Well, with that, there's a lot more sophistication to that design. So using smaller machines in these spaces, we're seeing more and more of that. So I might have derailed your question a little bit, but we're just trying to have the conversation with you. We're seeing more rating applications going on. The contractor that's putting down the asphalt or the concrete, all the base work that goes into that, now they can do it. Sometimes they sub it out, and those specialty base contractors are using these smaller machines with attachments. And sometimes now they're like, maybe we could do this ourselves because we have this attachment to a machine we already own. So they can really up the level of their existing equipment and use some of their better operators to get the better finished product before they put down the concrete or put the asphalt on top of it.
Yeah, I mean, and you have not derailed anything. I mean, because I think that this dovetails really nicely, because I think that the next kind of question that I have really is, you've mentioned, obviously highway work. You've mentioned kind of like the retail space. There's obviously the tighter spaces that are, some of these urban housing solutions, even not necessarily urban, but like suburban housing solutions where the space is just getting tighter and tighter, right? So like there's I feel like if anything, there's more and more opportunities for these type of grading solutions to be implemented by, various different types of contractors. So I guess like the next question is, with that, it seems like we haven't really peaked in terms of the growth of the category of machine or this technology. How much runway in terms of growth do you still see this kind of category and the technology having in the next several years?
It's not even within sight. I mean, every day we are thinking or getting contacted by a new niche market. We look at all the people that are using these machines. When we look at the numbers of compact track loaders, compare that to dozers. In any given year, it's about 8-1. Now, is every one of those doing fine grading, doing machine control applications? They're not. If we call it 6-1, there is a bunch of machines out there that are doing these unique things. And what are they doing? They're building sports fields. They're building equestrian arenas. They're doing motocross tracks. They're building trails within these new suburban neighborhoods for biking and walking. There's just so many applications and when we look at, the contractors that are performing these tasks, machine control isn't something they've really focused on, because they've been exposed to it maybe at a World of Concrete, a ConExpo, a local trade show, but it's always been such a heavy price, and it's been feature set to the big machine. So they just are under the impression that that's not for us. That's for a dozer. That's for a motor grader. So it's up to us to kind of make sure that we're showcasing to these applications and contractors that are working in non-traditional machine control markets to show them these are what you could do with this machine. These are what the returns would be, and this is how you can improve your final product and improve your overall operation.
Yeah, and I definitely want to get back to kind of like the potential returns, obviously the benefits later on, for sure. But
Yeah, sure.
let's talk a little bit about, you mentioned earlier, obviously 2D and then 3D. Let's talk a little bit about the differences between 2D and 3D, because a lot of machines now, even from OEMs, are coming, even some CTLs are coming with maybe like a 2D solution kind of included. Or you can add a 2D solution as like an aftermarket solution as well, obviously. But what is, for people that, like you mentioned, are kind of like new to the idea of getting grade control and putting it on a CTL, give us the difference between like the 2D option and what you would do with that and when that's appropriate, and then the 3D option when you might want to upgrade to that.
Okay. Apologies in advance because I do talk with my hands a little bit. So we could get fired up here. But when we're looking
No worries.
we're looking at 2D machine control, the two dimensions that we're measuring with that would be height and then slope in conjunction to that height. So that's worked really well. I think most people are familiar with using a rotating laser on a grade where we would get a laser moving around, we get a strike on it, and we'd know from there how much to go up or down. So that's going to give the contractor, the grade setter, a number that would be the cut and fill. So at that given spot, when I take a shot, I know, okay, that I need to bring the material up so much or cut so much out. So that's the first dimension, is height. And then we have slope in relation to that. So that if we've got a pad or anything going on, and it's not just, a cut, it can be a cut with a falling or increasing slope in conjunction to that. So that is typically a laser-based application. We've also used sonic sensors in the past, a depth finder, if you will, so that we know what we are, and that gets used in the paving world a lot. So we could use sonics or lasers to get our two-dimensional height, and then we have a slope sensor that adds the second dimension to that. What the limitation of 2D is there's no boundaries, meaning I cannot see where the job starts or ends. That laser just goes on for as long as the range of that laser is. So when we get into 3D, what we're doing is now getting a position on a job site. So we're going to have height and slope, but I also know where I am located within that area. So with that, I can now handle transitions in grade. So if we just had a flat pad that just had a cut or fill on it, and maybe a slope on it, okay, no problem. But some of the applications that we talked about before, let's take that parking lot, for instance, at the new strip mall. Well, there's going to be all kinds of features within there, and compound slopes and different drains and maybe a curb line and then a tree. All those things are happening at different elevations. If I was using two-dimensional measurements, I need to reset the laser anytime I'm differentiating between that height or that slope. So with using 3D, I now know the operator or the grade setter knows where they are within that. They also see the boundaries. So they can be working on a brand new area to be cutting out the tree lines or whatever the property lines are, and not working outside of those job boundaries. So there's a lot less day-to-day setups because they can be working from any angle and any segment of that job site. And because they are positioned, all of that information is relevant to where they're working at that given moment.
Yeah, so I mean, it sounds like, the big difference there with the 2D to 3D, and it makes sense because like any kind of upgrade in terms of the technology you're outfitting yourself with, I mean, it's going to up your efficiency, your productivity, and it's so there's time savings, and then there's greater accuracy, obviously with the 3D system because it's adding that third dimension. But what types of jobs might you be okay with like a 2D solution? But then what types of jobs kind of really lend themselves where you're like, okay, if you're doing this, you're probably cool with 2D. But if you're wanting to kind of do this type of job and you're wanting to do it faster and more efficient, this is when you should really start thinking about 3D as a viable investment.
Yeah. So to me, a 2D job, if we've got a smaller area with a very open sight line and we're just sticking to basics, we just want to bring an area up or down, control the material that's out there, have a nice, flowing slope on it, and there's not a lot of complexity to it. That's a great 2D application. And the nice thing about what we're doing with our 2D product now, I mean, that is something that we could talk about a little bit, when the time suits. But what we've done a facelift to our 2D product, and it very much is it's a 2024 product. We're working off a tablet now, as opposed to an old analog box that, sometimes people might think is the only thing that's offered in 2D. So people can start with 2D and move up to 3D. So it's nice that we can, move them through the products and it's scalable. But back to the question of where am I going to use 3D? 3D is if any sort of compound or complex design where we've got multiple things happening. So there's different elevations. Like let's imagine a subdivision. Subdivision is built and maybe each lot is on a stair step. So it's a little bit higher, a little bit lower. If I was using 2D, I need to go stop, set up the laser, move that every time. And then when I change over to a different variable of measurement elements, I need to go reset. Every time we reset, we got the potential for human error with, transferring the height of the instrument. So we kind of get into some surveying principles and practices that need to be adhered to. When we go 3D, all of those elements have been built into the digital terrain. So if you ever hear the acronym DTM, they're talking about a digital terrain model. And that would be the blueprint that has been digitized to be at the viewable of the grade checker or the operator of the machine. They can now see that on their tablet. So there's never a change that needs to happen after that is done, as long as they're within range of their GNS solution or their total station. That will reposition them and realize, okay, you're on lot 4 now, not lot 3. Let's change these. Anything that is, further out, the limitations of 2D is sightline. So if we've got a laser, we can only go so far. So if I was building a bike path or something that's kind of going off into the distance, then a 3D GNSS application or opportunity is going to be better suited to that, because I'm going to have corrections coming from satellites out of the sky. And as I move into the distance, I'm still going to have that availability of the corrections coming in.
Yeah, absolutely. So, I mean, and I think that kind of takes me to, kind of the next question about, in terms of the equipment that you have. You mentioned a lot of, like, especially with the 2D stuff, you're kind of, you've got the rotating laser, but a lot of the limitation is kind of like, 2D jobs, is it a constrained kind of like area where you're not losing anything on the horizon or within sight, and it's all kind of like pretty uniform? But then, like you said, with 3D and getting kind of like the corrections from the actual satellites, I think the bike trail analogy is like a really fantastic one. That's like the perfect, like, there's going to be changes in elevation, there's going to be changes in slope and everything else. And then obviously that's going to wind through past like a point that you can actually see. It's a perfect analogy. But what are the kind of like necessary components for both the 2D and the 3D system? So like, what stuff do you need on the machine? What stuff do you need external to the machine for both the 2D and the 3D systems? To give kind of folks like an idea of kind of like what are the loadouts for each technology type.
Okay, so I'll talk about 2D first, because a lot of that will build into the 3D system. So what we're doing with our 2D system is we are putting all of the additional hardware onto the attachment itself. So to talk about that real quick, I think the advantage to that is the attachment then becomes transferable. So if I was to outfit a motor grader or a box blade with the 2D-MC technology that we have, I've got more than one job site going on, I literally could load up the attachment, disconnect it from the CTL, take the attachment to the other job location and hook it up to the CTL that's on that spot. So it gives me a lot of flexibility with that. In terms of hardware that we put on it, we put a couple of poles on the attachment, and those poles house our laser receiver. So we put the laser receiver on there, and then we have our cords that come down and plug into our receiver box. So the receiver box is mounted on the attachment itself. So they plug into that. And then what we have from there is we're using a ruggedized outdoor construction tablet. And the 2D-MC software runs on that tablet. But the receiver that's mounted on the attachment generates a Wi-Fi Bluetooth signal to the tablet. So the only thing that goes into the CTL itself is the construction tablet. What I like about that is there's no modifications that need to be made to that CTL. So we don't have to cut or weld or have a window open. The tablet being on board in the CTL, it's so much easier for an operator to just look at the tablet compared to what they used to do, where they had to kind of look out through the glass and see a control box mounted to the attachment. And, what if it's dusty or dark? We have a tablet right there, and you can put it wherever you want it. Some people want it up here, some would like it down at their feet, some on the pillar. So it's very user definable as to where to place that tablet, which is their best line of sight. So they get to pick. Different people want it in different places. So that's what the 2D system looks like in terms of hardware. In terms of our MC Mobile, that's our 3D system for the compact track loader. We scale it up a bit. So if somebody wanted to start 2D and move into MC Mobile, they could. There's hardware from 2D that can go forward, but we place it in some different spots. So with CTL MC Mobile system, we add some IMUs to the solution. So we put an inertial measurement unit on the body of the machine, and that sensor is going to measure if there's any pitch and roll in the machine itself, the compact track loader. So as it's moving up and down a hill, there's cross slopes. That's going into the measurements. We put another sensor on the hitch of the machine. So that's just before it attaches to the attachment. And then we put another sensor on the attachment itself. So what we're trying to measure and capture is all the movements of the combined unit of attachment and CTL. They become one, and our measurements allow for all of those movements to be captured. Because what we also do is then we put the pole, instead of the laser receiver being on there, we would have a GPS receiver. So we're capturing the GPS coordinates off that receiver, but translating them down with all of those movements and the math that goes into it to giving us coordinates at the cutting edge. And now we have coordinates at the cutting edge is then calculating what's the difference between the current cutting edge and the final we want that's been designed into that model. So the operator can see the cut and fill.
Yeah, so and take us through we'll stick on this one to just the 3D system, but take us through kind of like the typical workflow. So we now see kind of like all the equipment on the machine and the measurements that those are taking, so that the corrections can be made according to the site plan. But take us through the workflow of using a 3D system, starting with like getting it set up, getting the design files, and kind of like what it's making corrections according to, and then finishing up with like using the actual kind of machine in the field. Like what else are we kind of missing beyond kind of what you've already kind of described?
So the Topcon MC Mobile system isn't a machine control system only. What we are furnishing is a workflow. So what we're really trying to do is get technology out to the non-user. And one of the difficult parts for the non-user is trying to figure out, which base station should I buy? How do I do this? Or what software do I need? Who's going to do the design? So what does it look like if everything's available as one package? So we've got a workflow. And what we're trying to do with that workflow is allow that contractor to be self-sufficient. So we call our MC Mobile workflow the ability to get in and get started, do everything yourself. So what we do with that is we now allow, because that tablet can be used as the data collector, a tablet goes out on a pole, just like your grade rod. So your grade setter, or that might be yourself if you're a one-man show, are going out to measure up and lay out the job yourself. So you can go out and capture the boundaries. So previously, you maybe had to have a surveyor come up and get you started. Or maybe let's go back, it's very simple, and somebody's just giving you a landmark. It's going to be 15 feet east of the fire hydrant and come in 10 feet, and that's the spot. Okay, great. And that's not a lot of sophistication, is it? So what if we had that, but we could actually measure and create the boundaries, the lot corners themselves? So in the measurement area of this, we set up, and now we can put in the lot corners. We can put in the boundaries that we need. Because we furnish the design software on our tablet, once that's done, the person can then get into tailgate design. I like to use the term. If they're building a simple design, they can just jump back in their truck or sit on the tailgate and start putting in the elevations or the landmarks that need to happen there. Because maybe I have the lot corners, but I want to put the driveway in here, and there's going to be a lazy river. There's going to be some rocks going in here. Whatever we're wanting to do, that can be done on the tablet itself for a simple design. Now, if somebody wants to do a big complex design, or it's getting done by a third party, that can still happen. But in terms of having a workflow, the tablet itself takes the place of a laptop and design software, because they can do these designs right there on the tablet. So they're doing design in the field. I like that for the simple fact that, sometimes you're doing a job and something changes. Somebody shows up and says, oh, I didn't know that was going to be there, or this isn't going to work. So because you've got the ability to do the design, you can also do a modification right there on the tablet and change what's going on. And then once that is all done, you can walk over with that tablet and get into the machine itself, and that machine becomes the operator interface. What was traditionally a control box is off of this tablet. So we like to use the term measure, design, build. That's our workflow. And in the MC Mobile package, you're getting all the components to complete all of that.
That's great. That's fantastic. Yeah, I mean, I think that obviously, to me, that's one of the biggest kind of advances over the last, 5 or 10 years is kind of like that, the consolidation of all those kind of separate pieces or data points, I guess, that have now kind of consolidated into, and I love that you guys are using the word workflow, because I mean, it's something that can be scaled to like whatever job site or job that you're looking at. Exactly what to expect. Each step of the way what you need to do, and it kind of makes everything a lot easier to plan around. In terms of thinking back to the machine itself, so we've kind of talked about the equipment on the machine, obviously like the power and the scalability of like this tablet interface that you guys have created for both measuring and then also kind of observing and reacting to corrections as the system is being used to actually build in the field. But are there any considerations when you're thinking about like the CTL that you either have or that you're thinking about purchasing or renting or whatever? If you're going to plan on using it with a 3D system, what are the considerations that someone should take whenever they're choosing a CTL for one of these systems?
I like that question because it's one of the things that we like to be involved in or kind of just point out. How much tractor you have, how much push unit, CTL, whatever term you want to use, needs to line up with the attachment. What you don't want to be doing is getting an attachment that's too big for the CTL you're using to actually move any material. So there is some bulk and some mass to the attachments. So getting a machine that's got enough, ground pressure and enough horsepower to move it around when it's got a loaded head of material makes sense. So, it's good to compare the specs of the attachment that you're buying or renting or going to use, or the one you have, to the output of the compact track loader that you're going to pair with it. A lot of the attachment companies, have their size that they sell the majority of, but a lot of them do sell units that are a little bit smaller. So it does make a lot of sense, and it is a must to compare what are you going to use it for so that you've got enough machine to move it around successfully. Otherwise, you're going to be burning a lot of diesel and burning out a lot of tracks because you're going to be spinning.
Is there anything related to the actual equipment and the loadout that people need to know? You mentioned kind of like you guys have gotten away from, thanks to the tablet, kind of like having to kind of crane your head out the window or look externally from the cab thanks to the tablet. You mentioned kind of like, especially on the 3D system, the internal measurement unit, the sensors on the blade. Is there anything from that standpoint, or have you guys kind of gotten to a point now with like the actual sensors and the equipment that it can be mounted to just about any relatively recent machine or even maybe some older machines? Is there anything around equipping the sensors that people should know about, I guess?
Not so much the sensors, Wayne, but what the big jump in technology from what we used to use and we used to have to do with machine control systems is CAN bus. Our system, we're talking to the CAN bus of the machine. So with that, we're able to work through the electronics of the CTL. And what we don't have to do, and has allowed us to get to the price point, is we don't have to put an extra hydraulic valve on there. So it used to be a long time ago, there's been people using CTLs for machine control for a number of years, but they were kind of taking dozer systems and motor grader systems and have to make them work. And then they'd have to put a hydraulic valve on there, and they would have to tie into the hydraulic lines and have the right flow rates. And we have just got to a spot where it's not necessary. We talk to the CAN bus of the machine, and with that, we're talking to the electronics to use the existing hydraulics. So we save a lot of time and installation and having that cleaned up, but there's not a lot of extra hardware out there, and we're getting the output that really was designed by the machine manufacturer. So it's just such a cleaner install, and that's really been the leap in technology is the ability to talk to the machine's electronics with our electronics.
Is there a certain, obviously new machines are going to be able to do that, but is there a certain, and I would imagine it depends on kind of like the harness that each manufacturer has designed or kind of moved to as machines have kind of advanced over the last several years. I know several of the manufacturers have redone that harness for various things, whether it be moving away from pilot controls to E over H, or if they're exploring electrification possibilities, et cetera. Is there a certain year range of machines that you should really be looking at if you're wanting to take advantage of those newer kind of capabilities and going right into the CAN bus?
Yeah, our focus is all on the current machines, maybe back a generation. I mean, if you go back a machine 10, 15 years old, okay, we probably can't talk to the CAN bus, but everything that's fairly current, we can talk to. So all the manufacturers, they realize it's a wide world. So they're, working alongside to make sure that everybody can play together, because there's a lot of opportunity here for all of the OEMs, for the attachment companies, for the technology companies. So bringing that all in together just makes a lot of sense.
Yeah, and I kind of I have a couple of things to wrap up here with, but the first one that I'd like to wrap up completely with just kind of like your thoughts on maybe like exciting things that are happening with machines that may augment machine control, kind of looking forward to the future. There's a couple of like neat little technologies that we've seen at ConExpo in the last year. Bobcat had like a display that's going to like, fill your entire cab glass. And then obviously I'm not asking you to speculate on anything like that, but just some little things like that might be cool augmentation of the technology that you guys build. But before we get to that, I want to talk about benefits of owning a 3D system. And, there's obviously kind of like the initial investment and how quickly you can get that initial investment back. But what are, beyond kind of extra productivity, the time savings, stuff like that, what are the biggest benefits to having a 3D system on your CTL? Can you give us like an idea of the amount of productivity you get on it, and maybe that ROI on a system like this and what you'd be looking at?
When we start looking at a CTL and the ROI, there's so many different segments that are going to, come out of your existing expenses. So it costs you money every day. In terms of production gain, 20 to 25% production gain is fairly achievable for most people. I mean, it really is. If you're putting this machine on and you're working 10 hours a day, you're going to, gain 2 hours in production every day by not having to stop that machine to check grade, by not having to shut down the machine while somebody lays out grade stakes, by not having to, like, really that machine should be in production mode every hour of the day. So that's what we're seeing in terms of production gain. But you look at all the other things that contribute to that. So, you bid any given job, and the job has requirements on it. It says, okay, we're doing, X, Y, or Z, and in that function, we need such a thickness of material. So you bid the job with that. But when you go out there and do it, who pays for the extra? So if your grade is not tight, and you're required to put out a given amount, but you're putting out more. So let's imagine it's, plus or minus 3/10, 4/10, whatever that is. If you're putting out 5 or 6, that's out of your bottom line. So we look at the production gain. Going back to production gain, if I speed that up and get on and off the job sooner, I can look at that two ways. If I'm an owner operator, okay, I can get home to my family and it's still not, 0 dark 30. I'm not getting home at midnight. So I can get home at a reasonable time. But I can also get more jobs done in that given year. So if you're looking at, maybe you cut North America in half, you got the frost line and you don't. But if you're some of those contractors that are working in somewhere where you have seasonal work and you used to do X number of jobs in those 9 months of construction season, but now you could do another third as many or whatever that gain is. But if I can do more work in the same amount of time, how much does that change my life? Getting home to do office work and see my family, how much does that change my life? And then when we look at material management, if we are tight on our materials and delivering what needs to be given to that job, but not going into overages, that goes directly to my profitability line. And I cannot how those extra materials that were expense or that were wastage, all those extra trucks that were hauled out there, that maybe I own the trucks, maybe I don't, all of those expenses that come in there, come in to take care of that. We talked about, measurement and layout. Am I doing that myself, or is that done by a third party? Because even if it's an internal employee, if I could have that employee doing something else, maybe I have them on the compactor, maybe I have them running a truck instead of going out and laying grade. If I'm bringing in a third party to do that, how much does that save me per job if I don't have to stroke a check for somebody's services to be doing grade checking or layout of that job? So there's a whole bunch of different factors that are all trimming the internal expenses to move that towards having a better profit line. I also like to talk about, you can get a better operator. So if I'm using, because what we haven't talked about, Wayne, is we've been talking about 2D and 3D, but we haven't really specified that we're actually using automatic controls. So although we have all those positions, whether they were 2D or 3D, that cutting edge of the of the box blade or the motor grader blade is tied into that elevation. So we're now going to make the pass to accuracy instead of chasing the pass back and forth, making 3 or 4 passes. Maybe I'm making 1 or 2 because the automatics are tied in there. But if I'm dealt with, having a newer, greener operator, having that automatic control on there gives his skill set a whole bunch of bump up. Imagine if I put machine control on somebody that's got a couple of years experience with them, then they just become a precision operator, and they can put that stuff out there with expertise. So, and we talk about not having the exposure of having rework. So if I'm using a 3D design and now I know where everything's supposed to be, I'm going to bring down the chance of ever having to rework or regrade something because it's either too thick or too thin, or it's in the wrong spot, because I have my onboard grade checker. I've been looking at that tablet and it showed me exactly where the job is, and all of the complex compound designs that are within there. Operator efficiency of the overall operation, material management. I mean, you could even get into safety. If I don't have to put somebody out on that pad to be checking grade, what are the chances of me running somebody over if there's never somebody out on that pad? I mean, let's face it, construction is a dangerous place to be. So, if we can eliminate the human factor of having somebody on that work area while the machine is running, to me, that's a big benefit too. So, I mean, we look at all of these contributing factors to the bottom line. This opportunity just makes a whole lot of sense.
Yeah, and I think that unfortunately, a lot of the time, this conversation gets contextualized or framed around the CapEx and the impact of the bottom line. And what gets lost is the improvement to the operation and the improvement to the operation's quality of life, like you mentioned. I think those are two really, really big keys. If you're an owner-operator that can get home earlier than they normally do or can do more jobs in a year, I mean, the more jobs in a year obviously has an impact to the bottom line, but there is also a quality of life impact there too. The safety thing, obviously a huge impact to quality of life. And I think listening to, obviously different jobs are going to have different ways and different operations are going to have different ways that this technology can impact. But I think that that's one of the big reasons why you've seen, whether it be state DOTs or highway contractors or whatever, for years have been proponents of having the machine control technology and have been really, honestly, that segment of the industry has kind of been ahead in terms of adoption than others. The efficiency gains, obviously, but then the safety gain, those are all if you can just tell me my operate, not just productivity or efficiency or accuracy or safety, but the operation, the quality of the operation and the work we do is going to increase by 3x, just in general. That goes beyond the discussion of kind of is it on time? Did you do it under cost? It's just that at that point, it's the operation as a whole is being improved. And that can be hard to quantify. So there's a reason why it's kind of tell me I'm going to spend what, and then how quickly am I going to get it back? So there's a reason because typically a lot of that's just the way that I think that things were run for the longest amount of time. But there's so many different inputs and outputs now that something like this is going to have a much broader impact than you can really just say well, your ROI is 8 months if you do this many jobs. I mean, it's obviously a much more complicated question than that. I love the nuance there.
Yeah, there's a lot to it. I mean, one of the things that I, we're talking to the dealers that are, or sorry, not dealers, we're talking to contractors that are, typically, greatly involved in their operation from start to finish. They are out there running a machine, or they're running the job themselves. But with this workflow, they can leave their operator, their operation, to maybe go bid another job because they have confidence that somebody can work without them being right there. One of the big pain points right now is cost of diesel. If you look at that operation, how much diesel are you burning on a daily basis? Well, how much of that diesel is being burnt to wasted passes? So if we can do something in 2 or 3 passes instead of 5 or 6, wear and tear on the machine, diesel consumption, more jobs per year. I mean, there is so much that comes back to the bottom line that when people get into this and the follow-up, interviews or check-ins with them, how are things going? A lot of the time it's great, and we should have done this 2 or 3 years ago. And you don't want to say, I told you so, but it's great to hear. And you like to see them being successful and getting better quality jobs. So the people that we're talking to that are getting into this for the first time are getting it and getting going. And their business is then scaling up because they are getting and bidding on better jobs. They're producing better quality. Yes. Their reputation is going up, and they feel more confident taking the risk to go for something and say, well, why don't I get this and go for here? And actually, now that we're making more money, maybe I should buy another machine and take care of this utility work myself. Maybe I'm going to start doing some of the trenching because I've been successful with all the CTL work. So it's kind of their step into this, but it's the opportunity to scale their business.
Yeah, it's a huge competitive advantage. And then you have to also think in certain segments and in probably certain areas, it's not even a competitive advantage. It's like if you want to compete, do you want to be competitive? Then the adoption is obviously growing. It's going to be something that you just kind of have to invest in. So yeah, super interesting moving forward. I want to finish up with one last question. I mentioned this earlier. New machine technology or thing that you have seen, it could be anything. Have you seen recently that has you kind of excited about the future of machine control technology? Or what thing may be coming down the line that's going to really kind of take this technology to the next level? I mean, you mentioned kind of the way that it can augment an operator's skills. And then you also mentioned kind of like the dynamic shift of working with like that external, but now having it all on the tablet. Like, what do you see coming down the line that might be a shift similar to kind of moving this thing to like a tablet that can be used as both input and output within the cab?
So there's a couple things, and really I'm excited about the overall compact machine control industry. And what I look at that is, you keep seeing the publications and all the different media pieces. Every given month, there's another OEM that is stepping up to now be in the compact track loader world. So that list of available machines, what we see on the full-size dozers, okay, we know the big 3 or 4. And then you move that over to CTLs, and that list is, well, now it's 12, now it's 15. There's more names coming into this space. And then the names that are here are building more machines. You look at, there's going to be a new model, this one coming up, it's a little bit bigger. And so it just keeps getting wider and wider in terms of how many machines are out there. In terms of our offering, I mean, we're so excited about this and seeing such success that we're going to keep expanding upon it. And our goal here is to keep it simple. We want to make sure this is achievable and is exciting for an entry level contractor to say, you know what, I want to enter machine control. What does it look like? So with doing that, we keep our MC mobile package simple and versatile, yet scalable. So if they all of a sudden, bring this into their environment and start using it and then say, what if we got some bigger machines? What does it look like? Well, they're in the Topcon environment, so we can have some cross compatibility into having bigger machines in there. The MC mobile package itself, and we were going to keep doing more and more things. We talked about where we place stuff. Some of the offerings we're coming out with now is a mastless attachment, so that GPS, GNSS head that was out on the attachment then can move to the cab of the machine. And with that, if it's on the cab of the machine, well, maybe I can use more of those attachments, whether they be in indicate or automatic mode. Maybe I put a ripper on there, a grinder. Maybe I do something for moving out trees. So it's just, we are really at the infancy of what this can do. And I go back to that 8 or 9 machines to 1 ratio. there is so many people that haven't been introduced to machine control because they haven't seen that fits what they're doing, that we're really at the, just starting out. So what does the future hold? I don't know. We got tons of technology we're going to keep on bringing out, but our biggest mandate through my vision, looking out through the glass in front of me, is talking to people that haven't seen it yet. We need to make sure that you realize that this is available to the business that you're working in, and these are the benefits that will come back with getting into this space.
Really well said, Mark. Well, man, thank you so much for joining us on Machine Heads. We really appreciate it. Love the conversation, and we're looking forward to everything you were just mentioning too. So be sure to come back on and join us again whenever you guys have more to talk about. But again, man, thank you so much for joining us to talk about 2D and 3D solutions. I think that anyone who watches this is definitely going to have a lot better kind of understanding of the options that you guys offer, but just some of the possibilities and everything in terms of improving their business and the way it operates. So thank you again, Mark.
I appreciate you having us. It was great to talk with you and go through a few things and share it out. So let's do it again sometime.
Absolutely. All right, Mark. Have a good one, bud.
Okay, thanks.